Welcome to the HL7 Open Source Tooling series. Today we welcome David Otasek, who is a software developer for Smile Digital Health. David does development work and maintenance work for the FHIR core libraries alongside the FHIR management group. He will be sharing with you the FHIR Validator, hopefully an in-depth view into this tool that you can use, and we'll take questions at the end of the session. Please put any questions that you have in the Q&A box or the chat, and we will get to as many as possible when David wraps up. Welcome, David.
Thank you, Sandy, and thanks, Mel, for being in the background and giving technical assistance. I'm David Otasek. I'm a software developer at Smile Digital Health. I assist Graham Grieve in developing and maintaining a variety of tools used in the FHIR community. I have 3 years of experience with FHIR, so I'm still relatively new to it, at least in context of all the people I work with. And in a previous life, I developed data visualization software for bioinformatics research. Today, I help develop and maintain the IG publisher, the FHIR specification publisher, and several different incarnations of the FHIR Validator code, which we are going to take a look at today. At various intervals in today's presentation, you will see links and URLs. Please take a moment to screen cap this slide or write down the tiny URL link. I will also put that in the chat after the presentation. Both will take you to a page that lists all the URLs I visit. It will contain any necessary contact information and some sample commands that you might find useful. I will also repeat this slide at the end of the presentation, so don't worry if you miss it the first time around. I will also suggest at times that you get in touch with Graham or myself on Zulip. Zulip is a large chat community for FHIR, where you can mention us in streams or channels or message us directly. We will also respond to GitHub issues on all our projects. And if you mention us there, it can draw our attention to particular issues. So for simplicity, when I refer to the validator, I'm referring to code in the HL7 FHIR Java tools that's responsible for validating FHIR resources. That code primarily exists in a project known as org HL7 FHIR core, or what we call the core library, or core. This code gets reused throughout a number of software projects. There are a number of ways that we can interact with it, and we're going to explore those today. The modern open source history of this project starts in January of 2019, when the code was initially put on GitHub. But its existence stretches back much further to around the time of the first FHIR dev days, or roughly 2012. Graham himself isn't quite sure when it was first created. I made a point to ask him during the working group meeting. I began to get involved in 2021, assisting Graham in developing and maintaining this family of open source projects. I was preceded in this role by Mark Ian Torno, also of Smile Digital Health, and James Agnew, the head geek and CTO of Smile, also made major contributions to this project. I encourage you to look up James's previous talk in this series about Happy FHIR, which is the open source Java implementation of the FHIR specification. And of course, this being open source, we have lots of valued open source contributors like Oliver Egger, Patrick Werner, and Lloyd McKenzie, to name a few. So the validator exists to solve a common FHIR problem, which is how to tell if any given data is a valid representation of a FHIR resource. If you're a FHIR implementer, an implementation guide author, or somebody helping develop the base FHIR specification, you'll encounter FHIR resources in a number of supported formats. Resources can be encoded as FHIR XML, they can be encoded as FHIR JSON, and they can even look like turtle files in the case of FHIR TTL. Each one of these, by the way, is from the same patient resource taken from the base specification examples. And what we want to know in each case is this resource adhering to the FHIR specification? Is the resource conformant? The long way around this problem is that you check the content against the FHIR specification. You go to hl7.org/FHIR. You find the patient resource listed in the level 3 administrative section. There it is right there. You click on that, you get to the patient resource specification, and then you painstakingly read the entire specification and verify that the resource follows it. Fortunately, the FHIR specification is designed in such a way that you don't have to do this manually. It contains conformance resources, such as structured definitions and implementation guides, which can be used to logically check for conformance to the specification by an application. The validation code in the core Java project implements this validation logic. One of the fastest ways to interact with it is through the Validator CLI, or command line interface. We'll look at that first, and then we'll explore some other tools that reuse the same open source code that it does. So let's take a look at a simple path of using the Validator command line tool. Before you begin, you'll have to meet some prerequisites. You're going to have a computer. Ideally, it should be running a recent version of Mac, Windows, or Ubuntu. You'll have to have Java installed on this computer, and its version will have to be greater than Java 11. And you will need to have some familiarity with operating in the terminal environment for that computer. To install the validator, you are simply downloading an executable jar file. If you're familiar with Java, you know what these are. If you are not, you will have to familiarize yourself with using Java just a little bit. You'll be able to find it at the stable link here, which will be included in the tiny URL, which is always the latest release. New versions of Validator are released frequently, and it's not uncommon to see several point releases inside of the same week, or sometimes even the same day, depending on how fast people are developing. All the previous releases can be viewed and downloaded at GitHub. If you follow the releases link, you will find the release that you want, and just look for the associated Validator CLI jar file to download. Once you've downloaded the jar file, you run it with Java. In the simplest case, you'll have a file containing your resource in an appropriate format, and you just enter it as the first command line argument. In this case, we're using my example patient JSON taken from earlier. So running from left to right in this string, we're running Java. We're using the -jar parameter to tell it to run the validator _CLI jar file that we downloaded, and we're giving it our patient.json file that contains our resource. If all goes well, the validator will start to run. Depending on the resource you're validating, the speed of your internet connection, and the speed of your computer, this could take anywhere from a few seconds to several minutes. As it runs, it will log what it's doing in the terminal output, and that will look something like this. Near the beginning of this output, you'll have some crucial information. Validator is going to tell you which version of the validator you're running, what directory it's being run in, what directory is being used to store any packages that it might download, what version of the FHIR base spec it's using to validate against, what locale and jurisdiction the host computer is set to, and what parameters were entered. If you ever have trouble with the validator, be it with the actual validation results that you might feel are incorrect, or if you encounter any strange errors, and I'll show a few of those later, we will likely ask you for this information, and it's pretty important that we get it in order to be able to replicate your issue. After this, the log will report what steps the validator is performing. And finally, it will come to the most interesting part, which is the validation result. In our case, because we took a happy path with a valid resource, we're just being told that our validation was successful. There's only one note or one issue, which conveys to us the information that everything is okay. I wish for all of your validations to be exactly this easy. If, on the other hand, we give the validator something that does not conform to the FHIR specification, we will see a different result that could look more like this. Failure. Instead of success, we have failure. We have a count of all the reasons for the failure, and then a list of individual issues that the validator found. Each issue is going to be given a severity from this set. We've already seen two of these issues, success and info. Success, which indicates that the operation was successful. Info, which contains any additional information regarding the validation process. And then outside the happy path, we get three other types of issue. You can have errors, which means that something in the resource has caused the validation to fail. You can have a warning, which means something in the resource was not consistent with best practice, but has not necessarily caused the validation to fail. And then you have fatal. That issue is when something has caused the validation operation itself to be unable to complete. If this occurs, the validity of your resource could be undetermined due to either bugs in the software or a failure of a validation service. So to simplify, if you have errors, your resource is invalid. If you have no errors and no fatal issues, your resource is technically valid. If you have warnings, your resource is technically valid, but you should probably investigate if you are following best practices. So let's take a browse through some of the issues that the validator found in our invalid example. For simplicity, I inserted some content in the resource that looks intuitively wrong. It is also technically wrong. And we're going to look at how the validator determines all of this later in the presentation. Our first issue is an error. This is one of the reasons that validation is failing. Errors and warnings will contain line and column information that will allow you to find what part of the resource it's referring to. Each issue will also have a message which explains why it exists. In this case, you'll see that the patient resource contains an unrecognized property called favorite color. You can probably guess that the FHIR patient specification has no favorite color. Note that the validator isn't complaining about the value of that property. In this case, it doesn't care if FHIR engine red is a valid property value. It just doesn't like that favorite color exists at all in this resource. Next, the validators found an error in using a vehicle identification number, or VIN, as a code for the patient identifier type. Note that there's a bit of a disconnect here between the reported line and column and the location in which we find the VIN. It's reporting line 11, where the VIN is actually located at line 14. Disconnects like these happen because the validator logic might be operating on the parent of a property instead of the property itself. If you see a line in a column that doesn't immediately make sense, look at the message accompanying the issue. The message will tell you what's wrong and will indicate the places that you should look. Our next issue is a warning, which is related to the earlier error. Notice that the message is also giving us some guidance. It's telling us a value set it's expecting codes to come from. We're going to explore exactly what that means just a little bit later. And it's looking for the value set identifier type codes. And finally, we get two errors, both of which refer to invalidly formatted date and date times. Both use a date value of 44002.3. This is a format that is only used in the Star Trek TV series. It is not in use in present-day medical records. The validator has given us a clear listing of what is non-conformant. In many cases, it's indicating what is actually required to make the resource conformant. We can make educated guesses in some cases, but to truly understand what the validator is telling us, we need to better understand the process of validation.
Thanks for watching. If you found this helpful, give us a like, subscribe, and hit the bell so you won't miss the next one.